we're good to start. We're good to start. Okay, well, brilliant. Thank you very much, everybody that's come here to join. Is that clearer? Yeah. Thank you, everybody that's come to join us here today. My name is Mark Pickering. This is Jamie Burrows, as you can see from behind us. We're here to talk to you about how food systems can adapt to an era of water scarcity. We're going to start by just having an introduction for ourselves and why we have something we think is relevant to discuss to the topic. I'm going to set the scene a little bit on a large global perspective. Jamie's going to talk a little bit about the specifics for the Middle East associated with water scarcity, and then we're going to talk through some general comments around solutions available at a very large macro level, and then talk specifically about some of the specific solutions that we offer from the company ourselves. So if I can pass across to Jamie to introduce himself and to introduce Vertical Future, and then we'll move on to the general topic at hand. So over to you, Jamie.
Thanks very much, Mark, and good to see everybody today. And I'm going to repeat myself by introducing the company for those that were here yesterday. But my name's Jamie Burrows. I'm the founder and CEO of Vertical Future. We are a global vertical farming technology and data company. We've been around since about 2016, so one of the older companies in the sector. As I said, we're very much focused on the technology and data side, so we're effectively the picks and shovels and the data for the industry, for the growers. Our view of the market is a vertical farm is a long-term infrastructure project that needs to be able to deal with objectives and goals a long time into the future. This is not a short-term project, and we're very interested in the data side of things because the ability to make a vertical farm more productive in every sense, including water, which is the main topic today, is very much dependent on data, which is why we have in-house proprietary SaaS platform. We maintain most of our IP. We also manufacture our systems in-house, and we're a very research-intensive organization, looking at anything from speed breeding to strawberries to the use of our systems in other sectors as well, so pharmaceuticals and nutraceuticals and so on, and alternative proteins. So we've done a significant amount of work. And yeah, it's a pleasure to be here today to talk to you about water and food security in the MENA region in particular.
Thank you very much, Jamie. And my name is Mark Pickering. I am the Chief Commercial Officer. I am the Chief Commercial Officer for Vertical Future. I joined the company 3 months ago, having spent 25 years in banking and finance. So forgive some of them looking down onto the notes, as I'm much more of the money guy than I am necessarily the individual associated with a significant amount of research into the area. But I'm also arriving at it from the perspective of an observer. I'm coming at it from the perspective of having wanting to take myself out of a particular industry into another that has purpose and has a measurable and deliverable impact into some of the challenges that we need to solve as a species for us to survive. A lot of the conversations that have taken place at COP that I have observed have been speaking about circularity, about ecosystems, about the means by which component pieces provide the effective elements to compound the impact on the other pieces. Water, specifically as relates to food security, is incredibly important. It's the principal bottleneck around delivering food security. And the impact of food and water and climate change, and the impact of climate change on the availability of water in a circular economy is an incredibly important aspect. Looking at it on a big picture in relation to food systems, 1/3 of the global greenhouse gas emissions are coming from the global food systems. It is contributing, food systems are contributing to their own problem. They're impacting climate change. Climate change impacts the availability of water resources. The impact on climate change on the water resources creates floods, creates droughts, creates problems in their own right to the production of the food systems, which obviously are getting more and more impacted by the impact of climate change on the principal availability of water into the process. Looking at it at a big and a significant macro level, 30% of the global population is moderately or severely food insecure. That is a significant issue on a global stage. There are 4 main crops that produce 2/3 of the world's food calories: rice, wheat, maize, and soybean. And the production of these, 72% of them are concentrated in just 5 regions: China, India, US, EU, and Brazil. The vast majority of all China's production is locally consumed. India is one of the most significant exporters of both rice and wheat. And the sensitivity, particularly to both China and India, to water insecurity is substantial. In a recently published report from Citi, they modelled 3 scenarios of regions' exposure to water stress, and significantly looking at the region's exposure to extremely high water stress by 2050, modelling on 3 scenarios, one being the Paris targeted of 1.5%, the middle range where we're kind of trending towards now of temperature increases of between 2.5 to 4.5 degrees C by 2100. And based on the modelling that they put from that perspective, 70% of rice and 78% of wheat produced in India are produced in areas that are significantly at risk of water stress by 2050. Remembering that in India, India is the 2nd largest producer of rice and the 3rd largest producer of wheat, and is producing 40% of the global world's rice exports. Looking across at China, obviously there's a domestic market almost entirely, but in China the numbers are 58% for wheat and 54% for maize of land banks that are currently being used that are under a high degree of water stress, be that flood or be that drought, but over half of their current available lands are likely to suffer from a production perspective because of the water impact. Just from a financial numbers perspective, if you model through what that would have on a global basis to cereal prices, that's nearly 28%, or potential for up to an increase of 28% of prevailing prices, and a impact of up to 180 million people going hungry as a result of it. That, from a banking perspective, that means, and from a listed company perspective, there's $3 trillion of business at risk at that kind of financial impact of that water stress. How are the water pressures increasing with climate change? So on the modular, on the circularity of that, increasing temperatures are clearly affecting the evapotranspiration rates, which makes precipitation highly irregular, which leads into excess falls in some areas and droughts in others, making the areas of India and China in particular, a number of other areas, subject to food and drought. So that's the picture from a global perspective. Jamie, if you want to have a few comments around the Middle East in particular.
Thanks. So I think the first thing to say is that this is so I'm going to talk specifically about the Middle East or the MENA region, and first point to make is this is a global problem. And I think a lot of these discussions we assume are mutually exclusive when they're not. We have an interconnected global food and water system. We were aware of water wars that have been going on in parts of the world, and that will probably proliferate as things get more difficult into the future. But before talking about MENA, I mean, I can even talk to discussions I've had on similar panels in the United Kingdom. And it'll probably surprise a lot of people to think that in as little as 2 to 3 years, we're going to be facing water scarcity in London, in the south of the UK, which is a shocking statistic when you think about the fact that, you know, we do not have the problems that we have here in the Middle East. And a lot of that goes back to and this comes from government reports, a lot of it goes back to the infrastructure that we have in place for that. But if we think about the MENA region, things are far worse, and they're going to get far worse if we don't come up with solutions. Solutions we're going to discuss a bit later on. I'm going to give you some statistics, but really we have an acute, far more acute lack of water for life and livelihoods in the MENA region. From 1960, we've gone, I think we've had about a 400% increase in population to around about 500 million people now. And if we're looking at 2050 as our next major milestone, well, 2030 is the next major milestone, then we look at 2050. Up to 2050, we're going to see probably about 20 to 25% more people in the MENA region. In terms of the countries that are affected the most, you've got countries like Iran, Iraq, Syria, Egypt, and Morocco. These are really the top 5. The reasons that it's more acute in those particular countries, a lot of that comes down to population growth, but also population distribution, and also water management and policy, which is something that we're going to talk about. But if we think about this population growth and population distribution piece in the context of increasing temperatures, which are obviously incredibly difficult to deal with, and the fact that we have to produce roughly 60% more food in this region and globally to deal with population increases, this is a really uphill battle. And going back to Mark's point, and I think a point we made yesterday as well, you can't talk about food without talking about water. They're very, very interconnected. So really interesting statistic here actually from the World Health Organization. So by 2030, the average annual per capita water availability will fall below the absolute threshold of 500 cubic meters per person per annum, which is a shocking statistic. And if you look at some of these reports and you look at the impact that will have on the more low-income countries and populace across the MENA region, it's significant and is a very worrying statistic. So again, it leads to the question of what solutions are we developing today, and what's in the pipeline for the future to actually deal with this. In terms of share of GDP, it could be anywhere between 6 and 14% of GDP on average across MENA markets by 2050, just to deal with water, which means that there will be probable economic trade-offs with other economic priorities would be the underlying assumption there. To date, I think there have been, in terms of what countries have been doing, and it's differed from country to country, there's been more of a focus on supply side tactics and solutions as opposed to demand side management, and that's been I don't know if it's been necessarily poor judgment, but it again has differed from country to country, but it's definitely something, you can't have one without the other. You need to be looking at a multitude of solutions to deal with the problem. And then just one other statistic, which is quite interesting, is water withdrawal in MENA is 83% compared to 70% average globally. Again, not a surprising statistic considering how hot this region is. And if you think about, turn the discussion to food, even in the UK, if we look at productive greenhouse farming, some of these greenhouses can get up to 50 degrees in summer, and that obviously has a direct impact on water consumption, and obviously makes a lot of farming non-viable, really. If we look at this region, in some countries we're getting up to over 50 degrees, and it just doesn't make crop production sustainable, which is why if we look at import statistics, clearly most crops are coming from overseas, and that will be the case for the foreseeable future, which leads to the question, what can we do here? What can we grow here? And how can we manage the water to be able to grow here? If we don't do this, there will be not only continued water wars and massive issues around price inflections, as you're seeing in food, but social unrest and a lot of more severe geopolitical issues, which have been very contentious in the MENA region in the past, as they have been in most countries around the world. So solution-wise, clearly we come from the controlled environment agriculture sector. Vertical farming is a subset of that, so I can talk with a bit of experience to some of this, but we can also talk about some of the wider potential policy and also macro solutions. So I'll hand back to Mark for that piece, if you want to cover that, or do you want me to? I can carry on. Okay, cool. Keep my flow going. So policy side, I mentioned that there are supply and demand side factor policies that have been implemented in different countries, and I think that there needs to be more of a focus on demand side and localization and decentralization of water management. And this has not been the case in a lot of these countries that I've quoted. I don't know if that's particularly the case in the UAE, but that gives us better control over water management and the choices that are made. Obviously different regions have different levels of infrastructure as well, and this can be very challenging, which means you have to have different approaches from a demand side and policy perspective when you're managing water. Desalinization, I think roughly 50% of water in this region comes from desalination. The issue you have with desalination is it uses roughly 23 times more energy than getting water from more standardized purposes. Desalination, I'm a big believer in desalinization, and I think that it's the way forward for this region in particular. But we do need to be wary of the carbon footprint associated with that, where we're getting our energy from. The good thing about MENA is with solar, with rising temperatures, we can benefit from very, very low energy pricing to obviously power those desalinization plants to provide that water. And there's already been a lot going on taking place in that, and I think that's probably going to continue into the future. That goes back to the question of capital, but we do know that there's been some big announcements at COP28 already around investment, and hopefully they extend to water and desalinization as well. In terms of, I think I'll leave CEA solutions to last. There's also behavioral change. Now, behavioral change is challenging when it comes to water, because when you're dealing especially with lower income populations, where it's very much kind of hand to mouth, the way that they're living their lives, and it's difficult to talk about behavior change in that context. I think it's much easier in more developed economies, and of course you have more developed areas in the MENA region and some more underdeveloped areas, but I think that that's something that definitely needs to be looked at, and how that's looked at from a central government or a decentralized approach begs the question. We don't know, but we think it's something that government should definitely look at. So delegation of autonomy to utilities and their managers is the main point, and locally elected government managers. This came actually from a WHO report, which I would encourage everybody to read. Then there's subsidies to create opportunities to actually monetize water savings. My background is in health economics. I've focused my PhD on incentives and pay for performance in things like healthcare, and so I'm a big believer in incentivizing change, and obviously getting rewards for things that address very important topics like climate change, water utilization, food waste, and so on, are things that should be enacted at every level of the country and within corporations and so on. And I do know that there is a lot of positive work that's going on in that area. Then there's dealing with the negative externalities. So you've got this irrigation efficiency paradox, which I'm sure some people have heard of, where people talk about a lot of grandiose technologies, and you go through a phase where actually the technologies are implemented, create more problems than they actually solve. I think within our particular area, controlled environment agriculture, the question still remains. There have been a lot of claims about savings in water, but I don't think the sector's really been running long enough to be able to fully validate what we can do in terms of water consumption, and also how that's going to change over time as temperatures continue to increase, especially in greenhouse or glasshouse farming in this region. Continue cross-sector research. I mentioned that we're very, very focused on research. We can't do this as standalone organizations in black boxes. There are leading authorities globally that specialize in water. There's leading authorities that specialize in the different types of crops that we should be focusing on. In the previous panel, we spoke at with WGEO. We focused a lot more on food and vertical farming, which I'll talk about next. But I think the biggest problem that we're going to have is growing staple crops. So vertical farms, as we know, have focused more on a very small percentage of actually the calories that are required for humans, the energy that we get from consuming food. It's the wheats, the maises, pretty much the crops that we're getting between 50% and 2/3 of our energy from that we need to focus on. These are very water-intensive crops because they grow for a long time. The idea that you can recover all water from any technology-led growing process is false, and because just like humans, when crops are grown, they take water with them. So it's impossible to recover all water, but it's something that will never be achieved, but we get as close as possible. So if I talk a bit about vertical farming and what we're doing, actually I'll talk about glasshouses first. Glasshouses, you've seen a lot of innovation. So I've been to visit glasshouses in the US, in the Middle East, and also in Southeast Asia. And they all have relatively similar approaches, and depending on where you are. So for example, in Southeast Asia, it's very, very humid, also have high temperatures, not as acute as you see here in the MENA region, but very simple approaches in terms of water recovery for the ability to actually cool greenhouses, which is very interesting. Simple tech, also things like biochar that people are using for greenhouses as well. So a bit of innovation there, and it's not really that complex, but I still think that a lot more needs to be done. In vertical farming, where we can't grow as many crops to full maturity as, for example, a greenhouse or broadacre farming, but we can work alongside them. We find that we have much better water recovery rates and statistics than glasshouses and obviously broadacre farming. So you've probably heard of a lot of figures. Your typical vertical farming company will quote 95% less water consumption compared to traditional farms. It's a very standardized statistic. The reality is it really depends on the type of crop you're growing. If you're growing some herbs, they don't suck up a lot of water. You grow them for a short period. Clearly, your statistics are going to be better when you're comparing to broadacre farming and greenhouses. But if you're looking at crops that you're growing to full maturity over months, obviously they're going to be a lot more hungry. So we have different technologies within our vertical farms which really allow us to recover as much water as possible. One is collecting water that's been, you've got water transpiration rates, the water that you don't see that's leaving the crops continually. And the ability to actually recover that makes up part of the equation. But a lot of it comes back to how we're recirculating and treating and then being able to use water for as long as possible in a safe way without causing biological issues within the system, and also without having to apply too many chemicals and so on to actually to do that. So regardless of where we set up our systems around the world, we use reverse osmosis, which is a little bit energy intensive, but it means that we can actually deal with many different types of water qualities, which is very important because you've got very different water qualities in different parts of the world that you have to look at when you're growing crops. Then after that, typically we recirculate our water 3-4 times over before a lot of it will then go out to waste. But again, there's continual microbiological testing that's going on to see, and also looking at things like Legionnaires and other kind of waterborne diseases that can impact your produce and also the operators, particularly for Legionnaires in a vertical farm. So there's definitely a lot going on. I think in terms of the applicability for this region, clearly I mentioned it's going to be a combinatorial approach between productive, high-tech greenhouse farming. There are some parts of the MENA region, for example, I had the pleasure of going down to Oman and going up into the mountains, and there are 3-4 months of the year when they grow alfalfa, alfalfa supreme, which is a very important crop when it comes to feeding animals. And they also grow a vast array of other crops. So it's not that you can't grow products in the MENA region. There's certain areas, but for the vast majority, if we look at countries like Saudi and obviously the UAE, it's far more challenging. Clearly, we want to be building more vertical farms. Clearly, we want to be working alongside other actors in the area. We need to work with more genetic-based organizations to support us with the wider economics around this. So the reason I mention this is because if we want to address food security and water security, we need to be thinking about price parity. If you're improving the unit economics of your wider system through other means, it means that also, even if you're dealing with water but not at a fast of a rate, you can still kind of hedge against what you're doing in the rest of the system, so that you're actually providing that food at a fair price to your end consumers. So it's, again, nothing within a vertical farm is mutually exclusive. They all work together. So I guess conclusions, there's still a lot to be done. We're nowhere near where we should be in terms of the implementation of infrastructure. In our particular case, in terms of deploying vertical farms and greenhouses and so on, we're years away. It takes at least a year to build a vertical farm, then a year plus to start reaping the benefits of that for the local population. And the same can be said for productive greenhouses and so on. But I think before all that, we need to see a lot of the policy changes that I've mentioned. This has been a talking point for decades, and I think now that we're getting a lot more serious, there have been a number of COPs, and I think water needs to really be considered as I think we're in a water crisis, and I think most people would agree with that if we look at it from a global perspective. And then, for this region, it's even more acute, as I mentioned. So I'm optimistic, but cautiously optimistic. But I do think that we need to make a lot more change. And to quote the movie Top Gun, I was formerly in the Air Force, so I'm an enthusiast of aviation. I feel the need for speed. This is, which I think most people have seen that film and can probably understand. And I think that should really be one of the things that we take away from COP. We need to move faster, and we need to stop talking. I mean, it's important to talk clearly, but it needs to be about action. And that's been my disappointment from previous COPs looking back. But I really do think that we're at a very dangerous inflection point, especially for lower income geographies all around the world.
Any questions? Before we close, just opening the floor for any questions from our audience.
When you talked about this water crisis, I was thinking, is it possible to establish a label water saving project? Is there some experience with the label same as organic product? We develop water saver product with that to reduce maybe taxes or to have added value for this product. Is there some experience like there?
I'm sure there have been similar schemes around the world. If there haven't been, I think it's a great idea. I mentioned incentivization, and yeah, I think it's something that really we should, if we're thinking about carbon and we're thinking about food, we should be thinking about water, we should be thinking about energy. So I think that there are massive opportunities in that area. We haven't come across much of that. You know, maybe there are some other people here that could talk more about that. But especially in this region, I think it's a, you know, if we think about a toolkit of things that we need to do to address the issues around climate change and food security and water security and all that, then that's clearly something that needs to be included on the policy side.
And I think that's a really interesting component piece. Jamie spoke about how, at the moment, the addressing means by which governments with which the large-scale institutions adapt or deliver their services is on the supply side. The money that is going into the marketplace is around making the supply available for our usage. Creating demand-side economics makes a really interesting point about how you would create value and create funding for the savings, as you say. That's exactly the theory behind the carbon credit markets. Right? You're creating a value for something based off an element that is not economically valued up until the point that you put a value to it through the carbon credits. So I think the ability to adapt what exists in the carbon credit market for exactly the same on a water credit basis, creating an incentive to create vertical farms, to create an incentive to create controlled agricultural production, creating an economic means to create the means to save the water usage is an incredibly valuable way to create an economic incentive for people to save the water that is being produced. And we are spending a lot of time at the moment as an organisation looking at our LCA, our carbon footprint, as a means of using that as a process for which the economic value of the carbon savings with our equipment can be monetised as a means of making that capex a more efficient route. The thing I'm going to be doing on Monday is talking to the same people about whether they want to put a value to the water saved as well, because I think if you can create that, that is a fabulous a toolkit that makes sense. What?
I suggest that World Green Economic Organization work on this maybe idea.
Sure.
Any other questions? No? We have a water expert in the room, so I was hoping for one question from her. Can take the mic.
So, do you think there's a future of growing cereal crops and things like that in vertical farms? And then another one, it's not strictly water, but how are you dealing with the sort of energy crisis, particularly? We've seen energy prices rocketing in Europe and elsewhere, and obviously it requires a lot of energy for these systems.
This was not pre-scripted, but I was really hoping for this question. Can vertical farms grow staple crops? Yes, with a lot of help. You need pretty much free energy. You need cheap water tariffs. You need to probably downgrade some of the tech elements of it. So our farms are highly automated, but we adapt these depending on which geography we're looking at. So I think some people think that building a vertical farm that's highly automated, clearly you're going to be taking away some jobs compared to traditional farming, and because you want to make things more efficient. But actually there are some parts of the world where labor is cheaper, it still should be fairly paid, and it makes sense to actually to do that. So it's a question of bringing the capital expenditure for the investor down to a level that is acceptable, and then having that model in place. In terms of the types of crops, so I mean we've grown different staple crops, and it's not difficult to grow them, but the key question comes back to at what price are you going to sell them at? If we don't feel that we can get near or at price parity with the global commodity markets, which is a really uphill battle, then we don't see it as an endeavor it's an endeavor that should definitely be pursued. But building a large-scale vertical farm without having that level of assurance, I think is very risky. We've seen a lot of vertical farms go bust in the US growing crops which are supposed to be, which are very niche and should be a real money machine, but they've used the wrong technologies. They haven't worked with the leading crop scientists. We work with one of the leading crop scientists in the world who specializes in wheat, for example. So that goes back to my point around keeping the IP in-house, clearly, right? We do a lot of grant work where there's some shared IP and so on. But just because we're a private organization doesn't mean that we don't want to work with these people. And again, for us to kind of speed things up and hit our targets, we have to work with those people. And another interesting crop is that I mentioned it's two. There's alfalfa supreme. There's barley as well. We've grown those pretty successfully, but again, it comes back to those points that I made, and also scale. You need massive farms to be able to benefit from the economies of scale for bringing down the cost of actually building the farm, and that's on our side. On that piece, sure.
So, putting my finance hat on, the answer to the question from a finance perspective is to look at the components about what the costs are. Does it make sense to produce a vertical farm that's growing maize, wheat, cereal crops in an environment like the UK and the EU where land is expensive and energy is expensive? Then clearly not, particularly as you're producing something with such a low unit economic price at sale point. We're here to discuss water in a region that is incredibly stressed from water and has an incredibly huge consumption of those cereals that it is not growing itself and is not going to be able to grow for itself. Looking at the economic inputs that you would need for a vertical farm, it is the price of the land, and then it is the price of the major two inputs that you bring into that farm, which is water and electricity. So if you are going to be growing a cereal crop where the economics make sense of what it costs to start and what you can sell it into, it is going to be in this region, because land itself is plentiful and is not in demand, certainly as you get outside of the major cities. So you get land at an incredibly cheap price. Energy is equally very plentiful in this region, not necessarily always from sustainable sources, but it is incredibly cheap at its pricing point before you look at taking sustainable energy into the mix. So you've got cheap land and you've got cheap energy, and actually water rates are relatively cheap considering the scarcity of water in this region. So you've got the three principal points to actually make that work. And then the last point, because you are taking out the import costs of bringing the cereals into the region, you've also got a pricing point that you're selling the crops at a higher pricing point than you would if you were nearer Ukraine, in the middle of Europe, in the middle of France or Germany. You've then got the question of, are you going to be able to produce at the scale, at the volume that is going to make an impact? That's where just the sheer size of the capital comes in. So if we can get carbon credits, if we can get water credits, if we can get a capital that wants to look at this on a 20 to 50 year time horizon, like our farms last for a 50-year duration in its construction, then the funding model looks attractive. The issues around food security for the regions begin to get solved. So it is not implausible, but it is a big leap of faith to be able to make that jump. It is a capex all in excess of 100 million pounds worth, and that's a big leap of faith to take at a first go. So bringing the subsidies should make that less of a leap of faith. The reason we're working with the CGIAR is absolutely looking at some of the crop mixes. So taking dwarf varieties clearly helps putting it in a vertical farm, because that's the point that you get the scale. You don't want to be having 1.5 meters worth of crop just filling up space mostly in straw. Being able to do that at scale with their input and being able to produce proper tonnage out of the farm are really the next stages. But our hope in working with them is certainly in the next 2 to 3 years that we have some form of sizable facility that we are putting to work in some part of the MENA region. So,
just to add a point to that, around the kind of dwarf varieties and the genetics, gene editing that's going on within this space as well is quite interesting. So we're involved in, this is going to sound a bit wacky, but they do link. We're involved in a international consortium which involves NASA, University of Adelaide, UK Space Agency, looking at crops that can be taken to space, and also how we can adapt our system to actually go up, and that's actually an objective of the project, which is quite interesting. The interesting part about that is you don't want big, space is at a premium, right? If you're in a spacecraft, or which I'm sure Elon Musk will have developed in the next couple of years. So using that knowledge, and we're looking at other crops as well, and we're looking at crops that produce different things for pharmaceuticals and so on, we can take that knowledge from space and almost bring it back to Earth and apply it to what's going on here, because here's where we need to be dealing with the issues. I'd also say that there's so Al Gore, mentioned the inconvenient truth of climate change. I'd extend that out and say that a lot of this is an inconvenient truth for investors. Investors have to be able to decide how serious they are about actually achieving these targets. The returns on grains, for example, staple crops in general, are not going to be as lucrative, clearly, as some of the other crops that I've referenced. If they're willing to do that, to make that trade-off, and it's a certain type of investor, it's the infrastructure investors that you want to get involved and have a longer-term return and look at a project over a 20, 30, 40, 50-year time horizon, definitely achievable. But if we're talking about people who are going to put money in and expect a 5-year return, and if you haven't hit that, it's not possible, because you can only push plants so far, irrespective of how good your technology is. Your second point was around energy. The energy economics of vertical farming are completely, and extending to the wider life cycle assessment, are completely geography dependent and energy source dependent. So we've conducted LCAs which we'll be publishing in the next year in peer-reviewed scientific journals, which we'll share. I don't think any other companies have done this to date, and people should be doing it, because there has been a lot of greenwashing. I think we found, even for projects in the UK, that the difference between a wind PPA, versus a solar versus just buying from the grid is dramatic. If you're looking at wind PPAs in solar less so in the UK, it works. But if you're just buying from the grid, you're actually creating more of a problem. So it really comes down to that. And then, there are more obvious points about the efficiency of the system, how are you using that energy. We have our LED solutions, we use different types of LEDs that have different energy draws at different times during the process of growth of the plant, which bring out different expressions. And so, for example, growing, I think we had a 30 to 40% decrease in energy consumption, and on the flip side, a 40% increase in biomass for some plants under some tests. And that's just about tricking the plants and doing that. So a lot of it goes back to the science and the tech, but the main point is where you get that energy from and where it's based.
And the last point for me about the energy intensity, there's clearly been a number of our competitors who have been growers who have had poor systems who have gone bust because of the shock. That's an engineering problem as opposed to an industry problem. They have the wrong engineering, they have the wrong science, they have the wrong approach to doing it. Even at the stress levels in the UK of energy prices, our farms are producing at price parity and making a return for all parties concerned. So yes, it is a problem, but if you get the engineering right and you've got the fundamentals right, then it's not a problem. Which is as good a point as any to finish. So thank you very much, everybody, for joining us today. It's been a real pleasure to talk to you, to have you here with us. And reach out to us if you have any more further questions. Thank you.